Dear friends, welcome to the next lecture on our ongoing discussion of the topic mechanical drives. This is lecture number 16 related to that. और आज हम इस लेक्चर में बेल्ट ड्राइव के थ्रू कितना पावर ट्रांसमिट होता है और वो कैसे कैलकुलेट करते हैं उसके बारे में डिस्कस करेंगे. दैट इज पावर ट्रांसमिटेड बाय बेल्ट ड्राइव. So, on which factors the power transmitted by the belt or the power transmission capacity of belt is defined. As per general notation, consider these parameters. Let T1 is the tension on the tight side of the belt, T2 be the tension on the slack side of the belt. Let V is equal to the linear velocity of the belt when it is moving in moving condition of the drive, and let us denote power transmitted by the belt drive is equal to P. अब हम पावर ट्रांसमिशन कैपेसिटी जो है वो पावर की डेफिनेशन से ही डिराइव करेंगे. तो हम जानते हैं कि दैट पावर इज गिवन बाय वर्क डन पर यूनिट टाइम. हाउ मच वर्क इज डन in unit time is defines power. So let us put in further modified form that P is equal to work done, and that is given by work done is equal to force into distance moved, or we can say displacement. So work done is placed by force into distance moved divided by time, and still as it is known to us, this two term, that distance moved per unit time is nothing but velocity. So the equation modifies in this form. The power transmitted P is equal to net force into velocity. How much force is acting and what is the velocity? Now, as we know that the on the belt two tensions are acting. T1 is the tension on tight side and T2 on the tension on slack side, and both the tensions acts in opposite direction. Hence the resultant force, net force acting on the belt is equal to, that is given by net force is T1 minus T2. So the formula for power transmitted becomes P is equal to T1 minus T2, that is net force, into V, that is velocity, linear velocity of the belt. So this relation gives the power transmission by the belt drive. We have to note some points related to this. पहला पॉइंट है, दिस रिलेशन गिव्स द पावर ट्रांसमिटेड irrespective of the fact whether the belt is on the point of slipping or not. Here the tension induced in the belt while power transmitted, it is of that condition where there is a slip is going to occur, is there or not doesn't matter, but difference of two tensions, tight side tension and slack side tension, multiplied by velocity gives the power transmitted by that particular at that particular condition. मगर T1 एंड T2 दोनों का टेंशन रिलेशन का जो कंडीशन है फॉर डिफरेंट बेल्ट्स, फॉर फ्लैट बेल्ट एंड वी बेल्ट, दैट for flat belt the relation between T1 and T2 is given by T1 upon T2 is equal to e raised to mu theta, and for V belt it is given by T1 upon T2 is equal to e raised to mu theta divided by sine alpha. For this condition it is necessary that the belt is on the verge of slip. If little increase in tension is there, then there will be start of slipping on the belt. But For this power transmission capacity equation, that condition is not required at all. But for this relation, for the tension ratios in case of flat belt as well as in case of V belt, it is essential that the belt is on the point of slipping. That is necessary. अगर वो कंडीशन नहीं है, if that condition is not there, no particular relation is available to calculate T1 and T2. T1 and T2 को अलग तरीके से कैलकुलेट करने के लिए दूसरी कोई मेथड नहीं है. So T1 and T2 are calculated on the basis of this relation, and this relation applies, this relation is with condition that the belt is on the point of verge. So this was about the power transmission by the belt drive. In both the cases, either it is a flat belt or V belt. So dear friends, if you have any question, you can raise, you can write in comment. If you like it, then share with your friends and inform them about this. And also, for more such topics of discussion, you can subscribe the channel. Thank you very much.